Okay, we're in section 3, the examples. Let me just blow this up so we can see what we're doing over here. And, basically it says compute delta y delta x. This was known as the average rate of change, by the way. So let's put this down. So what's y? And I'm reading this. Y is a function of x, and that function is 3x squared minus 2x plus 5. So I want to tell you what delta y is. Delta y over delta x, and we'll compute these separately, by the way. Delta y in the interval, I want to point out the interval is going to be, they tell me the interval, the x's are going to be in the interval from -1 to 2. So the delta x is probably the easiest thing to compute. What's that going to be? It's going to be 2 minus, that's the upper limit, the lower limit. And what's that going to be? Fairly simple, it's just 3. All right. Now the other problem I got is the upper part, which is going to be y, evaluate the upper limit, which is 2, minus y, evaluate the lower limit, which is -1. Well, you know what? I got to do those computations separately. Let me put y evaluate at 2. Well, that's going to be 3 times 4, which is 12, minus 4, plus 5. Mistakes happen, and that's why we give you answer keys. And we want you to look at the answer key, by the way. 12 minus 4 is 8. 8 plus 5 is 13. I also want to do y of -1. By the way, this is 13 minus, let's try this now. What do you get? 3 plus 2 plus 5. 3 plus 2 is 5. 5 plus 5 is 10. All right, I got to do that computation. We'll check with the key later, by the way. 13 minus 10 is 3, and 3 divided by 3 is 1. So that's what delta y, delta x is. That's also called the slope of the secant line between those 2 points. Let's see how we did. And we got it. This is good. All right, so we did that. And they did mention it's the slope of the secant line. All right, so let's do the next one. And next one, I'll be honest with you, a little more difficult. And the reason that they're asking for the instantaneous rate of change of the function, blah, 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 blah. And it says, I'm going to read that in the blue area to you. But the bottom line is that, I guess we did something like this before. And you say, I can't remember that. But I got to write this down for you. So I'm going to point out, it still is delta y, the slope of the secant line, m secant. And I'll write that down for you. It's the delta y over the delta x. But, I'm noticing over here is, what I'm noticing is, I got the instantaneous rate of change. So I'm going to say the x, right, is going to be on an interval from -1 up to some number. Now, someone says, could it be a different interval? It could, as long as it contains the -1, I get close to 1, I'm okay. But I'm gonna say the x is from -1 to some number a over here. All right. I want to point out in this case over here, a is greater than -1. So what I'm going to do is I'm going to try to do it. So what do I get in the bottom? What's the delta x going to be? It's going to be upper, which is a minus a -1. All right. I think I can do that. Let's do the upper though. What's it going to be? Let's think about this. It's going to be the y evaluated at a minus the y evaluated at -1. Let's write down y of a, okay? That's going to be 3a squared minus 2a plus 5. Let's put down y of -1, right? What's that going to be? 3 plus 2 plus 5. Hope I'm not going too fast. What's that going to be? 10. So let's write down y of a minus y of -1. That's the delta y, by the way. So that's going to be 3a squared minus 2a plus 5 minus 10. I think I can do that. And what do you get over there? 3a squared minus 2a plus 5. I'm sorry, not plus 5, minus 5. Get my eraser out. Sorry about that. Because on bottom, a plus 1. Okay, someone says, what did you just do? I just did m secant. Now, what do we know about a? We know a is greater than -1. So what I want to do is I want to just factor that top. Let's see if we can do that. 3a and a, and on bottom you get a plus 1. I'm going to say 5 and 1. I don't know if this works. Let me see if it works. You get 3a squared. That works beautifully. You get 3a minus 5a minus 2a. That worked beautifully. Yeah, it works great. Now, what do I know? I can't say this enough times. A must be greater than minus 1. So what do I know about this? This couldn't be 0. So what do you get over here? 3a minus 5. All right. That's secant. Let me write that down for you. Now, what do we want? I know it's tough. We want to get really, really close. We want to make this interval so small that we get close to minus 1. So I'm going to say, like, what would be a good number for a greater than minus 1? I'm going to say, like, if you thought about that, this is minus 1, by the way. What's a good number that's really close to that number, but greater than that number? I'm going to say a concept here would be maybe minus 0.9. I hope you're okay with that. Then someone says, well, you know what? I think there's a better number to try. Minus 0.99. What are we doing? We're getting closer. Then someone says, oh, I could do even a better number there. I get this one over here. I hope you realize all those numbers are greater than minus 1. So then I got to start thinking about if a gets close to minus 1, right? From what side of it? Well, let's talk about sides. I'm going to call this side a right side. So I'm going to tell you this over here. I'm going to tell you this is to the right of the number. This is right. We have a notation for that, which we'll talk about in more detail. This over here. That does not mean positive numbers. It just means to the right of minus 1. All right, let me get my eraser out. I'm going to go back to this picture over here. And we're talking about this business here. We did the sequence of numbers. Now, what I'd like you to do is think about it. All right, now if you're thinking about it, what would you get? Like if you get closer and closer? Well, it's going to get closer and closer to what we call the slope of the tangent line. Well, I'd like you to think about it. So if you're at like, minus 0.9, and then minus 0.99, and then minus 0.999, you're doing a computation over here. You hope you start to realize that those numbers can get closer and closer to minus 8. All right, let me repeat what we're trying to do over here. Without doing any computation, we're starting to think. Taking these numbers here, plugging them in one by one. This number over here, well, 3 times those numbers can get really close to minus 3. If you look at, just think about that. Really close to minus 3. And minus 3 minus 5 gets really close to minus 8. So my prediction over here is the slope is going to be minus 8. That's my prediction. What do I mean by that? The instantaneous rate of change at the point x equals minus 1 is equal to minus 8. Let me read through this over here and make sure you understand that we're trying to read through things for you. And we're trying to encourage you to read too, by the way. You need to make sure you understand the examples read in class to do this. Granted, I may do things a little bit differently sometimes. You will not be given credit unless you know the proper steps. That is computing a sequence of secants from both the left and right, and then making a prediction about those slopes are converging to. I want to point out what I've done in class. I'll write this over here for you. You know what? I noticed my board's been moving around a lot. Let me just see if I can. I want to tell you what I did in class, though. I would actually write the table down for you. And what's that going to be? Minus 0.9, minus 0.99, minus 0.999. This is from the left. And what'd you get over there? Well, M secant was what? 3a minus 5. We did a lot of work to get that. And you plug them in. What do you get? And again, I would hate to see someone actually do the computation. I'll write it down for you, though. Again, a lot of times writing things down is going to prevent you from actually doing any kind of computation. And I'm looking at that over there. And what would I say? Well, it looks like it's going 3 times -1 minus 5, which is -8. All right. By the way, you could also do the right table. Let me point out what that means by that. If I were doing that, it would be A to -1. You could do the same thing. You're still going to get -8, by the way. All right, let me take a look at the next page if there is one. And next page, I always say these things are difficult for me. And the reason that I'm not very good at doing scale. I'm pretty bad at it. All right. Like even with this really nicely drawn picture over here, I have a really tough time drawing scale pictures. All right. But let's see if again, you know what I'm doing. I'm blowing this thing up. And you can blow it up as much as you like. I mean, get there really close to that number. And you see a line over that blue line is a tangent line. Another guy's a curve. All right. So let's read it. Let's see if we understand what they've read. With an initial deposit of $100, the balance in a bank account after 2 years is given as a function of time. And it's given this. And this is something you learn in Math 119. It's the growth of money. It's exponential growth. And so I'm gonna put my maxes down. This is T, time in years. T is in years. And this axis over here is money. So I definitely see that point over there. You see that? I'm gonna write the point down for you. The point here is going to be, what's the time there? Time is it's 0, and that's when you have exactly $100. Now, if you want a year later, I hope you realize that would be 100 times 1.05. It'll be $105. Right? Now, if you keep going and going and going, the money's going to grow at 5% per year. What do they want you to do? Let's read it. All right, let's be careful about this. All right, so let's be careful. What are the units of the ROC? So what the hell's the ROC? It's the rate of change. Well, the rate of change is going to be, I'll put this over here. The rate of change is really just that delta F over delta T. What's delta F? It's dollars. What's a delta T? The internet, it's years. So what's the ROC? It's dollars per year. That's done. All right, next. All right, this is tough. Graph this function and estimate the slope of the tangent at t equals 1. Okay. Well, here's my problem over here. I graph the function. I'll tell you what the function is. I graph this function. This is the function graph. This is f of t. Let's go over here. That's 100 times 1.05 t. By the way, I don't mind using technology. This was use of technology. And what they want me to do is get the slope of the tangent line at 1. So you know what? I'm going to think that whoever drew the picture, this is the tangent. This is M tangent line. And M tangent at the point 1. Right, you get the idea what I'm doing over here? And what's f of 1? 105. So how'd you do that? Let's go through that. If I put 1 up here, that would be 100 times 1.05. I'm glad I got that number. So I got one lousy point over here. Let me point the point I got. So I'm going to say, I'm looking at it, and I'm saying that point. It's 1, right? 105. All right, and I'm thinking the blue line might be 0, 100. I don't know. It doesn't look exact. I mean, there's no matter how you blow that up. I don't think I could tell that. Now, someone could say, "Oh, I want to take a point way out of here." Take a point where you like. I don't care to take the point. So what's the slope of that line? What's M tangent? Well, I got 2 points, right? Let's put that down. It's going to be a tough one, though, isn't it? So let's see. It's going to be 105 minus 100. And 1 minus 0. So I'm going to say the slope of that line looks like it's going to be 5 over 1 equals 5. I realize for some students, they might say, you know what, I used different points and I got a slightly different number. As long as you're around 5, I'm happy for you. 5 is about right. Let's see what this guy got, though. Ooh, I got a slightly different number. Do you notice when I said 5 and they said 5.1? I don't think I'm terribly upset by it. It's roughly the same number. Now, someone might say something, I get a different number. How'd they get those numbers? Maybe they selected different points and got different estimates. Maybe they selected this point here and this point over here, and they got different estimates for it. I don't know what they did, but they must have done something different than I did. I used those 2 points. And I got about 5. All right, what's the next thing then? Looking at the graph, do the slopes of the tangent line appear to be getting bigger as time goes on? I don't know. Let's take a look at it. So let's take a look at a tangent line over here. That would look like this. Let's look at a tangent line over here. It would look like this. I hope you can agree that the slopes of these tangent lines are definitely getting bigger. The growth is getting bigger over time. Now, why do we expect to see that? The principal is getting larger. Of course, it's going to be getting bigger. When I say the principal, 5% of it is being increased per year. It's getting bigger and bigger and bigger because you're getting interest on top of interest. All right, so the answer is yes over there. All right, we're at the interface now, and we're in the beginning of the course, and it's where a lot of students would say, well, what do I need to do? And a lot of them, they don't know what to need to do. And we don't want to say, we don't want to leave you in the dark here. At least we want to be honest with you. So I'm sorry about that. Our honesty is this. What you need to do is you need to study what we've given you, in these notes. You'd also want to read the book if you're really thinking about becoming well-educated. You need to start to read the textbook. After you study and read the textbook, though, your next goal should be wondering, would I be able to do problems that they're going to eventually ask me on exams? So what you have to do after you study and read all the stuff that came before, all that stuff that came before, reading the book, studying the notes, coming to class, paying attention, what you need to do is saying, can I do this? Can I do homework on my own without having someone over my back telling me what to do? I'm hoping, right? You need to do homework, including any web assigns that they're giving you. Does it take time and effort? You're not kidding. A college education, or an education in general, takes time. Let me review what the time requirements are, at least in the United States. First graders, that's grade 1, 10 minutes per night homework. That's after these poor little guys are in school for 8 hours. They have to go home and do 10 hours of homework. Second grade, 20 minutes of homework. Third grade, 30 minutes of homework per night. That's Monday through Friday, by the way. By the time they get to 12th grade, that's 120 minutes now, right? If you found the story. A high school student in the United States is supposed to spend 2 hours per night, Monday through Friday, doing homework. That is studying, homework. Study, 2 hours per night, 5 days a week. Here's the sad truth. A majority of people are thrown under the bus in the United States. We clearly understand that they have not put the time or effort into their education, but they're still pushed forward. A majority of students in high school do not follow that rule. They're doing other things, anything but that homework. Are they getting by? They think they're getting by, but they're not getting by. They're being pushed forward. Now, again, I'm going to say the student that's looking forward to a, I'd say a quality lifestyle is actually doing what they've been told to do, which is their homework. All right. You might say, I've never even thought about that before, but the homework is what you need to be doing. And that's the study department. Now, when you get to college, you're not in class 8 hours a day. It's much less. So then the burden becomes much greater. There isn't so much work being done in school, right? Like 2 hours of homework is nothing in college. In college, the requirement becomes this. For every hour you're in the classroom, you should be spending at least 3 hours of study time on your own. So just think about this course. It's a 4-credit course. It's actually more than 4 credits, but the school doesn't charge you more than 4. It's 4.5 credits. That's how much contact hours you're given. You were to spend 3 times that per week in the study department. So this class alone, it would be 4 hours a week in lecture, and you'd be roughly 4 hours. I'm just saying rough, and another 12 hours of study. Now I realize a lot of students they're smirking at this, saying, "I wouldn't do that. I don't need to do that. I have plenty of people I know that never have done that." You're being thrown under the bus. You just don't know that. And when you get thrown under the bus, you can get mangled. Now, granted, they might drag you out from under the bus to throw you back under it again and again and again. We don't want to see that happen. At least I don't want to see it happen. I don't want to see you being churned. I don't want to see you seeing Calc 1, Calc 1, Calc 1, Calc 1. In other words, we take you in, we try to teach you, try to do what you need to do, throw you under the bus, run you over, and then we drag you out, wipe the dirt off you and say, you know what? Let's give it another try. We throw you under the bus again. We want you to do this on your first try. We want you to do that. All right, let me talk about the other flip side of all the people in the United States are thrown under the bus. There are those people that are not thrown under the bus. There's those people that are working far beyond what you thought was humanly possible. Like I said, 2 hours of homework in high school. There are students in high school that are spending 6 to 7 hours outside of their classroom activities in the study department, not just Monday through Friday, but also on Saturday and Sundays. They may put in 12 to 14 hours of study times. What are they trying to do? They're trying to secure themselves a position where they're guaranteed not only a good wage, but a wage beyond their dreams, all right? A job beyond their dreams. They're looking forward to that. There's great rewards for people that are at the top of their game in the United States. And be aware of that. We want you to be in that game. There's only one way to get into that game is to work hard. And we want you to work hard towards that goal. If you have any questions or concerns, though, about the homework or what your responsibilities are, please come by and see me during office hours where we could discuss those issues. Thank you for your attention. Bye-bye.